Okay, in this video we're going to look at what we call the tangent problem. Now this tangent problem is sort of really important. It's fundamental to the development of calculus. In fact, it's this problem here which kind of led to the whole development of calculus. It's why calculus exists. So the question is, what is the slope of the tangent to the tangent line to the curve y equals x squared at the point 1, 1? Now this problem could be applied to any curve at any point, but we'll just take a fairly simple curve in a parabola, and at the point 1, 1. So if we know what a tangent is, we should be able to sort of estimate what it would look like. Just draw it. So it's going to look something like that. So we want the slope of this line. So what is the slope of L? Now, here's the problem. Here's why it's a problem. We know from grade 9, or wherever you learned about slope, you need 2 points in order to calculate the slope of a line. But with this line here, we only have the point 1, 1. We don't know any other points on the line, and that's kind of where the problem lies. So the question is, how are you going to get the second point? So how do we get a second point? Second point to calculate the slope. And the slope. So I'll get different answers when I ask this question in class. Like sometimes one of the suggestions, which is not the way we're going to do it, is some people will say, well, we can take our drawing and kind of just pick a point here and try to estimate what the coordinates are, and then that would be an estimate of the slope. And that's not a bad guess, but that requires that you draw a very accurate sketch, which is not going to give you a precise measurement, and one sketch was going to differ from one person to the next. So that's not the method we're going to use. What we're going to do, so that we can get an exact coordinate, is take another point on the curve. So let's take the point up here. Call this point Q. So let Q be another point, be a different point than P. Point on the curve. Okay, so Q will have the coordinates. It's sort of an arbitrary point, so it's just going to have the points x and then the y value. The y value is actually going to be x squared because it's the curve y equals x squared. So x squared is this point Q. So what I'm going to do is I'm going to look at the line between P and Q, and I'm going to calculate the slope of PQ. So calculate the slope of PQ. Now the problem here, or the way I'll abbreviate this is M for slope, and then I'll do a subscript PQ. The problem here is I don't actually have a coordinate here, so I'm just going to let x be a particular point on the value, and what you'll see is I'll change it to different points as I go. I'm going to try different values. So let's say if x equals 2, then Q is the point 2, 4. Right, so that would be the point right here, 2, 4. So I'm going to calculate the slope of that line. So the slope of PQ would be, we know the formula for slope, y2 minus y1 over x2 minus x1, or rise over run. So that would be 4 for the y value of q minus 1 for the y value of p over 2 minus 1. So that'd be 3 over 1, which is 3. So the slope of this red line here is 3. So therefore the slope of PQ, so no, let's write it. The slope of PQ is 3. Now from the drawing, you should be able to see that this red line here, the slope PQ, the slope of PQ is clearly more, it's a steeper line than my tangent. So we know that the slope of our tangent should be less than 3. So from the drawing, so we can see L, the slope of our line, has a slope less than 3. Or a slope less than the slope of PQ, which was 3. So we know our slope is less than 3, but how much less than 3? So in order to figure out how much less, or get an idea of how much less, change the x value. So instead of PQ being here, or Q being up here, what if it was a little bit closer? What if this was Q? And then I looked at that slope. So hopefully you can see that this slope will actually, the blue one, will have a less steep slope than this. It'll be a little bit closer to the slope of L. Now I'm going to have to do a bunch of slope calculations here, so what I'll often do is organize this into a chart. So this is the x value, and this is the slope of PQ. So when x was 3, so that's, sorry, when x was 2, that's the one we did. So when x was 2, when q was 1 unit away along the x-axis, we got a slope of 3. But then we said, what if we moved it a little bit closer? So how much closer? Well, let's say half closer. Let's say 1.5. So let's say x was 1.5. So I put 1.5 into this calculation here for x, and I'm not going to do the calculation. I'm going to let you do the calculation. But if you put 1.5 in for x, then your y value would be 1.5 squared, and you calculate the slope. If you do the calculation, you get a slope of 2.5. So it's smaller than 3, which is what we said should happen. You should get a slope a little bit less than 3, but it's still bigger than the slope of L. So that's still too big. So what if we made the point a little bit closer? So instead of 1.5, we made it even closer. So how much closer? Well, we can go a lot closer. Let's go all the way, let's go 1.1. So x is 1.1. Now put that value into your calculation here. And then you'd have to get the y value, which would be 1.1 squared, and then do y2 minus y1 over x2 minus x1, and work out your slope. So I'll let you do that. But if you do that, you'll get 2.1. So so the point's really close now, and it's getting closer and closer to the slope of the black line, L. So we got 2.1, but still the black line would have a slope less. So less than 2.1. Well, now the question is, can you get even closer? Can you get a better estimate? And the answer is you'll always be able to get a better estimate. Just go a little bit closer, like 1.01. Now that's really close. Put that into your slope calculation. You get a value of 2.01. You can go even closer, 1.001. You get a value of 2.001. And to get these values, you'd always have to be doing the slope calculation. So what we can say now, well, you might be able to say, okay, it looks like maybe it's about 2, right? It's getting closer and closer to 2. We don't know for sure that it's getting closer and closer to 2, but we do know we know that the slope of L is less than 2.001 because it had to be smaller based on the picture, right? Based on the picture, if your point is on the right side of P, the line is always going to be a little bit steeper than L. Okay, so we know the slope is less than 2.001. Okay, can we figure out exactly what it is? Well, we can get a good estimate from the other side as well. So um, let's say instead of taking that point Q and putting it on the right side, what if I put Q over here? And then I drew this line. So the line between P and Q. Well, now compare this red line here to the black line. The red line here is actually going to have a slope smaller than the black line. So if I work out the slope of this line and compare it to the slope of that one, I know the black line will have a bigger slope than the value of the slope of PQ. So I'm going to do the same thing I did before, but instead of x being bigger than 1, bigger than the point that I was given, I'm going to make it smaller. So smaller than 1, I need it over on the left. So let's start with 0. Let's start right here. I'll start with that slope. So if x was equal to 0, then I would put it in to this slope formula. So x1 is 0. This would be 0 as well. The point would be 0, 0. And I'd get a slope of 2. So I know that my slope I get a slope of 1. I get 1. Because you'd have 1 over 1. I get this line here would have a slope of 1. So I know that my slope for the black line should be bigger than 1. But again, I can do better. I can take a point a little bit closer. So what if x was 0.5? So 0.5 would be like right around here, right? So that slope's going to be a little bit smaller than the first one we did, but it'll still be bigger than the L. So if I put 0.5, I'll do the slope calculation. You put it into that formula, you get 1.5. And again, you can go closer to 1. You can say 0.9. If you did 0.9, put it into the formula, you'd get 1.9. If you did even closer, 0.99, 1.99, you got. And you can go as close as you like. Keep going. And it's when you get 1.999. You have to do the calculation, but that's what you'd end up getting. So we know, so therefore the slope of L is more than 1.999. So from this calculation, it's smaller than 2.01, and from this calculation, it's bigger than 1.999. So we can, to a pretty good degree of accuracy, conclude that the slope must be, it's between these two numbers. So therefore, the slope of L is between 1.999 and 2.001. Well, the number 2 would be a pretty good estimate, right? It could be something else based on this, right? There are numbers other than 2 that are between those, but we can be reasonably confident, at least to 4 decimal places, that 2 is a good estimate. So therefore, the slope of the tangent 2 y equals x squared at 1.11 is 2, or at least approximately 2, and 2 is accurate to at least this many decimal places, at least one more decimal place. So we'll just say it's 2.